And I will start this demo by stating the ultimate rule of thumb, the ultimate question you need to ask yourself in every networking problem in Kubernetes. The question you need to ask yourself is, how do I reach this pod? Or how do I reach these type of pods? That's the ultimate goal of any networking problem, okay, reaching a pod, because pods host our containers and they host our application. For the sake of this demo, I will create a deployment, okay, that will create a pod. So I will run this command. This command will create a deployment that will call ClusterIP app, and this deployment will bring one pod up that will run the container echo server, which is a web server that responds to request by some information about the request you just received. So okay, so our deployment is created. So now let's see if our pod is there. We're gonna get the pods with a wide output, and here we go. We see one pod, and we see that this pod has an IP. Okay, so that's good. And what we're gonna do now is that we're gonna try to reach this pod. We're gonna try to reach the echo server, okay, the web server running on this pod, by reaching it via its IP. Okay, so for now we're gonna be inside the cluster, so forget about all the outside world. We're gonna try to do pod-to-pod communication. So in order to do that, I will create another pod, okay, a client. So I will this will be like a sort of busy box, okay, that I will use in order to send requests to the first pod. And I'm gonna send a request to this pod. Okay, so I'm gonna take its IP, and I'm gonna put the port on which the web server runs, and it's 8080. Great, we're getting a response. Okay, as I say, the response is just some information about the request. So we have an information about the host name of the server, which is, well, the name of the pod here. Okay, and we have information about if we had query, request URI, all sorts of information about the request. Okay, so that was pod-to-pod communication. Now let's do something that will hopefully change the IP of this pod. Okay, so I'm gonna delete this pod, and so now we're gonna describe the pod. And now we see that the IP has changed. Okay, the name of the pod has changed. Okay, the suffix here has changed, and the IP as well. So if we want to run the same request as before, well, now we're getting an error because no pod has this IP. So now you see the catch with this method. The problem is that pods come and go. There's no guarantee, okay, that a pod will stay forever. Okay, it can die, it can be scaled up, a lot of things can happen to it, and the solution to this problem is services. Okay, so now I'm going to introduce the idea of services. So a service is simply an entity that allows us to communicate to our pod without having to know their IP address. Okay, because as we said, the IP address is erratic and change all the time. So what we're going to do here is we're going to expose this deployment through a service. So this command will create a service of name ClusterIP app service. Okay, and it will, as you know, 8080 was the port of where the echo server listens, and we're going to map this port to 80 in our service. So I'm going to run this command, and here we see that the service of that name is created. So we're going to describe the service, and we see the service has a type and an IP, a cluster IP. So this is the first type. There are 3 types of services. I'm going to expose all of them. So we have a type, cluster IP, an IP, which is the IP of this service, okay, and a port. Port is 80 as we described here. So what we're going to do now is that we're going to try to access the pod, but through its service. So we're going to send the same request, but at the IP of the service, okay, and this time not to 8080 but to 80, because this is the port the service is listening on. And here we get the same response. Okay, we get a response from the pod, because now even if I kill this pod, so now the pod has been deleted. Let's try to run the same request to the service, and we see that this time the request is successful. We get the new pod. Why? Because, as I said, the service is like the interface that keeps track of all the pods, okay, and we just later make the routing, okay. And there's also another thing that service allows us is to communicate to our pods by calling the service by its name, okay, and not just by the IP. So previously I called the service by the IP, but I can do the following thing: put source IP, and I'm going to put a dot here, and I'm going to put the namespace. Okay, my namespace is demo, and we see that we also get a response from the pod. Okay, so we can reach the service either through its IP, okay, it's a static IP, or through its name. So obviously in most of the cases we reach the services by its name, because it's much more convenient for us humans to do so. So this was services, but now remember one thing: our service had a type ClusterIP, and as the name states, ClusterIP is only accessible from the cluster. What can you do if you want your service to be accessible from the outside world, or from, for example, people that have access to your node? Okay, so there's one way to do this, and it's NodePort. Okay, so we're gonna edit the service, and we're going to change the type to NodePort, and I'm going to explain in a second what NodePort does. Okay, great, the service was edited. Now let's describe the service. kubectl get service, and we see that this time the type has changed, and also the ports. Okay, we can see that here another port has been added next to the port previously specified. So what is this port? So this port is simply a port that has been opened on all the nodes of your cluster, and on which people that have access to your nodes, that can call your node, can reach the service at this port. So consider for a moment those two cubes representing each one of our nodes on the cluster. Okay, so creating a service with NodePort type will open a port on each one of the nodes, and each node can from now on receive a request at this port, and will forward it to the service at the given port of the service. Okay, so in this case I have two nodes, I'm running on EKS, so I cannot access those nodes. They're in a private network, but if I could access it, and for example the name of my node was node 1, I could do node 1 dot 31.748, and this request would be transferred to my service at port 80, and I would receive a response. Okay, so a NodePort service is simply a ClusterIP, okay, service, but on which we additionally open ports on the nodes, and anyone sending requests, anyone having accessibility to our node can reach the service. But most of the time those nodes are behind a private network, as in my case. So there's a third type of services in Kubernetes, and it's a load balancer. So currently I'm running on AWS, and I'm gonna edit the service as I did before, and I'm gonna change the type to load balancer, and we'll see what will happen. Load balancer, like that. Okay, and the service has been edited, and let's get it. Okay, and now we see that we have an external IP. So what is a load balancer service? A load balancer service is simply a NodePort service, on top of which my cloud provider added a load balancer, meaning a component that can receive requests from the internet, so a component on which we provide an external IP, an external address, and this component will redirect the request to my service at port 80. So right now I can reach my service from outside the cluster, and I can reach it at this address at port 80. So if I do a curl command, so this time, as we see, we will pass through the internet, HTTP, and 80. We're getting a response from our pod. So we've seen three very different ways of reaching our pod, but it's always the same principle. We have one pod running, okay? It's called SourceIP app. It has one container inside called the Echo server. This container is listening on port 8080, and we only want to reach it. And now we also could reach it from the internet, okay, through the load balancer. To quickly summarize what we've seen in this video, we've created a pod running one container listening on port 8080. We've seen that this pod is assigned an IP address, and we sent requests to the pod, and we've seen that the request was answered by the container. But we've seen that this IP address is ephemeral, as when the pod dies, the IP address dies with it too. So we've introduced services. We've seen the service is a stable interface in front of our pods, and it just load balances the request it receives to any of our pod, no matter what the IP of the pod is and no matter what is the age of the pod. We've seen that services come with an IP address as well, and we've sent requests to the IP address, and we've also seen that it comes with a name and that we can access the service by its name. We've seen that in both cases our request was successfully forwarded to the pod. From there we have changed the service type to NodePort, and we have seen that when we do that, a port is open on each of our nodes in the cluster, and we've seen that from that point we can send requests to any of those nodes at this port, and the request will be forwarded to the service and from there forwarded to the pods. And finally, we changed the service type to load balancer, and we saw that our cloud provider provisioned a publicly accessible component with an external address. We sent a request to this address at port 80, and we observed that it was successfully forwarded to our pod. We saw that load balancer and NodePort service types are functionally identical, except for the cloud provider specific component that exposes the service publicly, even when we don't have direct access to the cluster nodes. So this comes very handy when we want our cluster to be protected, but we want to access one of the services on the cluster.